Good afternoon, everyone. Hello. We're about to start CEOS 102. Please signify if you're around by sending me a chat that you're available so that we can start. Maybe I should give you more time, like in the next 10 minutes. I'll start it at 10 minutes after 4. So I'm giving you 8 minutes to gather yourself together and listen to the lecture. So I'll come back in 7 minutes time. So this is 4:10. I said we are starting the class at 10 minutes after 4. And this is 4:10. So we can start now. So today, good afternoon, class. Welcome today again to another class on abstraction in computer science. Last week, we were able to treat analogies in computer science. Today, we are treating abstraction in computer science. It's a continuation of last week's class, but in another direction. So we can say simplifying complexity through essential representation. My name is Dr. Dukoyelu Atoyi from the Department of Software Engineering, Obafemi Awolowo University in Ife. Today, we are going to look at abstraction using these 4 points. We are going to define abstraction. We are going to explain abstraction in computing. We are going to identify examples, and we are going to discuss object-oriented programming abstraction. So at the end of this class, you should be able to define abstraction, explain it in the context of computing, give several examples that apply to computing, and peculiarly discuss the object-oriented aspect of abstraction. So what is abstraction? You always hear the word abstract. Abstract. Before now, or in the olden days, we used to think that abstraction was something we could not see or something we could not visualize. But now, using this slide, you should know that abstraction is not that. Abstraction has to do with hiding of some information, hiding information that is not going to be useful to you at that particular moment in time, hiding unnecessary details that may even confuse you or may make learning difficult for you. So abstraction is just a way of hiding those details and making the ones that you need available, so that you just focus on those ones to understand the theory or concept being exposed to you. So one of the definitions we have here is hiding unnecessary implementation details while exposing essential features. Abstraction is the process of removing those details to focus on those essential characteristics of a concept. So making learning easier and understanding better. It is a fundamental tool for managing complexity. And it only focuses on what and not how. So if you think of any problem, difficult problem, and you really want to understand that problem, you need to apply abstraction, meaning that you look at that problem at a very high level without looking at the details, ignoring the details. For example, now an architect will raise a building, but from the plan, the building plan of the architect, you notice that the buildings have different views, front view, back view, side view. But meanwhile, the real plan of the house, the complexity, the arrangement of the rooms and the parlors and the kitchen is what is complex in its design. So if you ignore all those details and just look at the building from the front, back, or side view, you are kind of applying abstraction to understand what the architect has done. But meanwhile, there are still deeper levels of the building, like opening the door and entering the house. That's when you now know that this is not just an ordinary building. So that's an analogy. I'm using that, the architect's work, as an analogy for abstraction. So if you look at it that way, you know that, okay, abstraction means what and not how. Similarly, when you drive a car, you then open the door, you sit in front of your dashboard. The only thing you do is to start the engine and the car moves. At most, touch the handbrake, then maybe you use your automatic gearbox or manual gearbox, and then you move. But this is just the outside part of or the higher level of the understanding of how to drive a car. There's something deeper than that, which you don't know about. But for example, a mechanic that repairs your car will know more than that. So what the mechanic knows and the engineer knows is the complexity behind what you are driving. So as a driver, you're just exposed to the outside or higher level of your car mechanism. But the mechanics and engineers are exposed to the deeper level of what a car or driving means. So meaning of abstract. Abstract represent essential characteristics while omitting unnecessary details. And why are we studying abstraction? It has reasons. Is a very big tool that we can use to reduce complexity, to improve our understanding of aspect, theories, and concepts, and to enhance productivity. Those are really three major aspects where abstraction is being useful to us. And that's why we are studying it. For example, now, when you talk of abstraction reducing complexity, it means we want to hide implementation details. Since the users interact with what a system does rather than how it does, it then prevents them from being overwhelmed by internal operations. So it helps you to be focused on only the operations that you need to understand. For example, when you use an ATM machine, you want to withdraw cash from the ATM, you insert your card and you press some buttons. And the only buttons you are exposed to is maybe deposit money, withdraw cash, check your balance, buy credit, all those many buttons on the dashboard of the ATM machine. But there are so many things that are being hidden from you. You don't need to know how the database is being queried. You don't need to know about the encryption algorithms that are being used to hide your information. Or you don't even need to know about the banking network communications because the ATM mostly is not, some even that are beside the banks still need network to be connected to their server. And some that need to connect to other banks to need network. So all those things, informations are hidden from you. You don't even know them. What you are exposed to is just the machine. So it's trying to reduce complexity for you. Another way it reduces complexity is that it reduces cognitive load. Most human beings, we can't keep too much information in our brains. We are limited in the amount of information we can keep. So abstraction will enable you to just focus on one level of detail at a time. And as a result, it makes learning and problem solving much easier. So you don't need to be exposed to the complexity of a problem or an object or a concept before you understand what to do with it or before you learn about it. It also supports modular design. Since complex systems can be divided into smaller independent components, where each component can be understood and developed separately. Hence, the developer only needs to know the interface of a module and does not need to know the internal implementation. So those are the reasons why abstraction reduces complexity. It allows modular design. It promotes reusability. It simplifies communications and it improves maintainability and also enables layered thinking. For example, at the user level, when you are browsing, you are using a browser. The only thing you are exposed to is a web browser. But there's a deeper level, that's the application level, which has to do with the operation system where the web browser is working on or working with. Then, further than that, you have the system level, where you talk about the hardware drivers. And then you have the hardware level again, where you have the electronic circuits. So layers of abstraction, they are encountering layers of abstraction. So someone that wants to browse and then is exposed to the operating system, may not be able to browse, may not know find his way around the system to browse. If you just expose someone to the MS-DOS prompt of a system now and tell the person to start browsing, you will get confused. But once he gets to the desktop and launches the web browser, the icon of web browser, and he starts browsing. So it doesn't need to know about the operating system, doesn't need to know about the drivers, doesn't need to know about how your system is being connected before it starts browsing. It improves understanding. As a result of all those complexity being reduced, definitely you have a clearer understanding of the subject matter. Your load, cognitive load is being reduced. You can organize your knowledge into levels and be exposed to the level that you can cope with. So for example, the other example I mentioned about web browsing, we can say that at the highest level, the web browser displays web pages. At the highest level, what you see is a web browser displaying a web page. Another level of abstraction is the intermediate level. At this level, you don't know what is happening. What is happening in this stage is that the browser communicates with the web server using a particular protocol called HTTP or HTTPS in case of a secure protocol. Another deep level, which is in a lower level to the intermediate level, data is being transmitted as packets over computer networks using protocols such as TCP/IP. So what you can see now, we have three levels: the highest level, which an ordinary user can understand, and intermediate and low levels, which can be left to network engineers or programmers to understand. So each level builds upon the previous one, making learning systematic. So if you use abstraction to understand a particular system, you focus on the level that you can cope with, and then from there, understand better. So it makes complex systems easier to explain. It improves productivity in the sense that when you want to build a system using pre-built tools like libraries, interfaces, will allow you to accomplish your work faster without having to understand the inner complexities or arrangements from scratch, or without having to build everything from scratch. So that's another advantage of abstraction. It reduces mental effort. So in this case, you only need to understand the relevant details for you to accomplish your task. So, and that speeds up learning and decision making. It promotes reuse. When you talk of abstract components like function, classes, and APIs, you can just use templates and use them repeatedly across projects, reducing duplicate work, and it enables parallel work. So as a result of all those advantages, you need to know about abstraction, and we need to know how to apply it in our diverse endeavors. So, as I said mentioned earlier, we have levels of abstraction. We have the highest level, the mid level, and the low level, which can be further decomposed into or rearranged into highest level, which has to do with the conceptual design, mid level, which can contain logical design and implementation, and lower level, which can be called the physical level of abstraction. So instead of three, we can also have four levels. And the second level being the logical design and the implementation design. We treat some examples, so if you are still confused, you don't need to panic. I'm still going to face some real scenarios so that they help you explain the concept better. So let us look at the highest level, which is the conceptual level, high-end abstraction. This is a very general, far from the details. This is very general, far from the details. So in this case, you don't need any details. It's what you see that you deal with. And it is called the conceptual level. It is the highest level of abstraction. It describes what the system does without explaining how it works. So in this case, you don't need to know how the system works. You just need to know what it does. Like the example I cited, mentioned earlier on, when you are driving a car, you only need to know how to start the engine, move your handbrake, your gearbox, the pedals, accelerator, clutch, and the rest, and then focus on where you are going. If you have to turn left or turn right, and etc. So you don't need to know about the inner complexities of the car. You don't need to know about what is behind your dashboard or how is the fuel moving to the engine. That's the transmission. You don't need to know anything about that. You're only exposed to the front wheel and stuff like that. So that is the conceptual level. Then we have the logical level as part of the mid-level level of abstraction. The logical level explains how the system is organized without specifying physical implementation. It describes relationships, structures, and processes. And the characteristics are that it focuses on the architecture, defines components, shows interactions, and it is independent of hardware. So that has to do with the logical design or abstraction, and that is the mid-level. It has to do with just functional systems. You don't need to know how the plumbing works. You just need to know that an electrician can operate at this level because he knows about the connection in a building, or a plumber knows about how your plumbing network works in your house. So the next level, under the mid-level, has to do with the implementation. This level focuses on how the design is implemented in software, and the characteristics include programming languages, algorithm, data structures, classes and functions, and API. So this level is deeper than the logical level, in the sense that here we need the tools that we use to implement what was described or organized or planned in the previous level is what is being described in the implementation or mid-level layer of abstraction. And then we have the last level, which has to do with the specific details and components. And that is the physical level of abstraction. This is the lowest level. It describes how the computer actually executes instructions. It includes CPU operations, memory addresses, registered logic gates, electronic circuits, and binary instructions. So this is the lowest level of abstraction. Here, you need to know how things work, not what they do or how they are arranged or how to implement them. You need to know how things work. Okay, so moving up the ladder helps with strategy, moving down helps with execution. So an expert or professional, we know where or which level to address whenever he wants to understand the concept. But you as a normal user, ordinary user, or layman, you always focus on the highest level because that's where we have very far less details. It's just something simple to understand. Okay, so why do we use abstraction? Just like why do we need abstraction? To reduce complexity, to improve productivity, to improve clarity and usability. Complexity management allows us to build massive systems like the internet by breaking them into manageable layers. Efficiency. You don't need to reinvent the wheel every time you solve a problem. I think I mentioned the fact that you can do what? You can reuse components. Okay. Reusability. Generic solutions can be applied to many different specific problems, and clarity improves communication by focusing on the big picture. So, as I said earlier on, I've been mentioning the car example on and on so that by the time you get to the slide, you understand better. As you can see here, you have driver sees the steering, the brakes, the accelerator. The engine complexity is hidden. It means that when you drive a car, you interact with the abstract interface, the steering wheel, pedals, and gear shift. You do not need to understand internal combustion, fuel injection, or thermodynamics to get to the grocery store. The complexity, thousands of moving parts and chemical reactions. So the complexity is being hidden from the owner of the car. But meanwhile, a mechanic or driver that wants to address any situation in your car needs to know the level to operate. He knows about the highest level and he knows better. He can go down to the another level of abstraction to address the problem because he knows more than what you know. So he can go directly to the internal combustion or fuel injection to solve his or her, to solve the problem of the car at any point in time. So can you see car abstraction diagram? You have the driver, the controls, and the leading systems. I think you have been listening so far. If you have any other example you can mention, you can suggest any of them. So, for example, for the driver now, the highest level is the driver. Highest levels view is the driver. Hmm? The driver, that means the person driving the car, not the mechanic, oh, the driver. What does he know? What can he do? He can start the engine. He can accelerate. He can press brakes. He can move the steering. So that's what the driver can do, right? Have you seen what the driver can do? So you can erase it now. What at the middle level, that's where the mechanic can operate. Middle level, sorry. Mechanic is here. He understands the engine. That mechanic understands your engine. He knows what is going on in your engine. He understands its transmission. He understands the fuel system. And he understands suspension or whatever technical word that is around there. So that's what your mechanic understands. That's the middle level of abstraction of your car. Okay? The lowest level, that's the lower level view, can be understood by another expert called the engineer. Or I think there's a name they call them, But let's use engineer. Okay? The engineer must understand the sensors. Most cars have sensors now. He must understand how the electronic control unit works. Electronic control unit of your car works. He must understand the fuel injection timing. He must understand the combustion process. And electrical circuits. So what we are saying is that each person interacts with the car at a different level of abstraction based on their roles. You see, so where we can apply abstraction. So abstraction is applicable in any environment. If you see a system or a concept, it has different levels of abstraction, which may be understood by a particular person or the other. So you can't expect someone to understand all levels. Someone can, but maybe some, not all levels. So to address a particular problem, you have to know the level to focus on. If you are not an engineer and you want to maybe work on a project that has to do with cars, why should you bother yourself, overwhelm your brain with things you cannot even understand? Face what you can understand and leave the rest to those that understand those aspects. Okay, another example now. When you talk of an ATM machine, as I said earlier on, the ATM machine, the highest level, that's the user. Anybody that is using an ATM. User view. What can he see using an ATM? When he gets to an ATM, what can he do? Let me get some suggestions from you. What can you do? When you get to the ATM, what do you do? What's the first thing you do? I'm waiting for your answers. I want to use an ATM machine. What's the first thing I do? You're not answering. Or you don't use ATM again. Withdraw. How do you withdraw the money? Do you just say, I want to withdraw money? How do you interact with the machine? Okay, what's the input? You put your card. So the user can insert the ATM card. Yes. Two, after inserting the ATM card, the user will enter a PIN number, 4-digit PIN number. After that, he interacts with the screen, the menu buttons, and he does what? Withdraws the cash. Withdraw cash. And in case it's a tenant that can accept money, can deposit money, he can check his account balance. He can check his account balance. If he has enough cash to withdraw, and he can print a receipt after withdrawing to know what he has left in his accounts, and so on and so forth. So the customer does not need to understand how these operations are implemented. What he needs is just access to his money and he leaves. But what is the other view of the ATM machine? For example, if the ATM machine has an issue, who can attend to it? Somebody that knows more than what the user knows. So that is the logical view. You can call that one the system view. Here, what happens is that this ATM software will be organized so that transactions can are into several functional modules. The ATM software can organize the transactions into several modules. For example, the first module, when you insert your ATM card, you can call that one the authentication module. Authentication module, because you are trying to prove that you are the person that owns the account balance. So you enter your card, enter the PIN number, and then once they ascertain that you are the owner of the card, they now give you access. So that is one module called authentication module. Another module under the ATM card, authentication. Another module has to do with the account management module. So a module that is in charge of your account, what is going in and going out of your account when you use your ATM card. So you can call that one account management module. Another module is the one that is transaction, has to do with transaction, whether you are debiting or crediting your account is a transaction. So, and has to be processed. So you can call that one transaction processing module. Don't mind my writing. I'm not using a pen, so that's why it's not so clear. Transaction processing module. Then you have cash dispensing module. Once you are done with the movement on the screen, withdrawing the cash, you are waiting for your cash. There's a particular section of the ATM where you see your cash coming out. So that one has to do with the cash disposing module. Then, if you want to print your receipt, that one is another section of the ATM that gives you a printed version of your receipt after you must have done the transaction. So, receipt printing module. And then once before your money moves from one bank to the other, what is in charge of that? Maybe the network. So that one too has to do with network communication module. So what I'm just trying to say is that at the lower level of the ATM abstraction diagram, that's the middle level. What you are exposed to has to do with the arrangement of the modules of how whatever you are doing on the screen, what is going behind the door of whatever you are doing on the screen. So your authentication part, your account management part, everything is going on behind the door. So if you are seeing someone using the ATM machine, it's doing a lot behind the door. So these modules work together to complete a transaction. So if these modules are not available, the only thing will happen is that you insert your card and nothing will come out. Nothing will come out because it is not going to complete the transaction. If there's a network glitch, for example, your card will just stay in the ATM and nothing will happen. It won't even come out. Or if there's a power failure, a lot of things will go and you won't get your money out of that ATM box. So the next level has to do with the implementation level. We have talked about the modules. And the modules are like boxes. What's happening inside the box? That's what we want to know. And that is only available at the implementation level. That's the next layer. So at that implementation level, the implementation level, you have The one, when you talk of transactions, when you talk of account management, you are involving what? Databases. And when you talk of manipulations, you are talking of programming languages. And then when you talk of authentication, you are talking about encryption algorithms. And a lot of banking APIs are being involved. Then you have security mechanisms and network protocols. So those are the things involved in the implementation level. Programming languages. Please give me a second. Tommy. My hand is not writing so well. There's not a pen. I could share.
My pro.
So we have programming languages, databases, encryption algorithms at this level. Banking APIs, network protocols, and security mechanism. So for example, when the customers enters a PIN number, after inserting your card, you enter a PIN number. So a software will encrypt it and send it securely to the bank server for verification. So that's a scenario under encryption. So the next level, we have mentioned 3 levels now. I've mentioned 3 levels. The first one had to do with the user. Second one had to do with the system view, which is the logical level. The user view is the highest level. The next level had to do with logical view. It has to do with the system view. The third level is what I've just mentioned here, the implementation level. And then the last level, that's the physical level. Is what we want to discuss now. So the physical level now, what do you think is involved in the physical level? Even from the word physical, know that anything that has to do with physical level is something you can touch. It's hardware. Okay, so the physical level here in the ATM machine. The physical level of the ATM machine, which is the lowest level. Lowest physical level, which is equivalent to the lowest level, has to do with the hardware components. So when you talk of hardware, when you want to press your pin, what do you touch? Touch a keypad. A keypad is being touched. When you are inserting your card, you call it a card reader. That one reads your card to know that you are the owner of the card. You have a screen where you see the information, called the display screen. You have a cash dispenser that releases your money after pressing buttons. You have the receipt printer And you have servers that are being uh, you are interacting with servers, yes, bank servers, which are systems on their own. And those systems contain CPUs, memory, network interface cables, circuits, cables, and the rest. So you see that one layer depends on the other. And without these four complete layers, your ATM machine cannot function. But understanding those four layers is not for you as a user. So that's why we have applied the concept of abstraction. And abstraction is only giving you what you need at the highest level, those details that you need. So the whole diagram is just depicting levels of abstraction of an ATM machine and telling you that, okay, at my level, the only one I can understand is in topmost. Anybody that wants to understand the other layers, maybe that person must be an expert in those areas. So if there's a mechanical fault with the ATM machine, I expect you to employ someone that will understand the lowest level of abstraction of an ATM machine, not someone that will only be comfortable with the highest level. That person cannot solve your problem. So those are the layers of abstraction. I think I've explained that. We still do some more examples later. So I've talked about the ATM abstraction diagram. Then we talk of abstraction in art. So as abstraction is being applied to objects like ATM machine, cars and the like, you can apply abstraction to concepts or uh, areas or disciplines. For example, we have abstraction in fine arts, in art. They too use abstraction in the sense that it, the abstraction they use. Share, sorry, I'm coming. Sorry for the interruption. Okay. So we are on this, where are we now? Okay. Okay, abstraction in fine arts. So in art too, they use abstraction in the sense that it helps them to move away from painting exactly what they see. They just reduce their painting. It's not that the main features will still be there, but they reduce some of the elements and they only focus on color, shape, and line. And having to use all this, definitely what comes out is a similar picture of what they want to represent, but with less details. And the goal for that abstraction in art is to capture the essence or spirit of a subject rather than its physical reality. And we have some examples of artists that use abstraction to design um, pictures, to draw pictures of human beings and to express some feelings. So Picasso is one of them, and he has used abstraction in the work of in his work in the olden days. I don't have a picture here to show you, but I've seen one. So what he did is to just use shapes, triangles, circles, and out of the shapes, he was just able to bring out the eyes, nose, mouth, and ears of a human he was trying to represent. At the end of the day, the drawing or the artifacts brought out a shape of a human being using abstraction as a concept. So the main features of that human being will not come out, but at the end of the day, you realize that what is being drawn is a human being. Sorry for not adding one of the um, pictures or figures representing Picasso's abstraction. But maybe next time I'll bring one of them. So now we move to abstraction in technology. We have discussed abstraction in real life scenarios like ATM and in arts, but this slide has to do with abstraction in computer science. And computer science definitely is under technology. So when you talk of technology, we are talking about programming language, user interfaces, application programming interfaces, and encapsulation. So those are the things you'll be focusing on. So computer systems abstraction. Here we talk about applications, operating system, machine language, and hardware. If you see the flow, you notice that anybody that is using a package, I think I use one example as web browser. You are using a web browser, is classified as an application, and it resides on the machine that is maintained or managed by an operating system. And that operating system too is residing upon a machine that uses machine language for instructions. And the instructions too reside on the hardware, which has to do with the physical hard part of the computer system. So this is abstraction in computer science. We have a more detailed arrangement for that, but not in this slide. Maybe in the one I'll send to you. Abstraction in programming. When you talk of print hello world in any programming language, this is just hiding a lot of details from you. It's hiding a lot of details. It's just telling you that print hello world will give you some results, but it is more than that. And let me see if I have a diagram for that one. Okay. Okay. So when you talk of abstraction in programming, you are given a problem to solve. A language, they said use Python to solve a particular problem. So the first level is the problem you want to solve. The next level has to do with the language, the high level programming language you are going to use to solve the problem. So give me an example of programming languages you can use to write this code. For example, you can use Python, you can use Java, you can use C++ or JavaScript. So the next level after that will either be a compiler or interpreter. And then next, the assembly language. After that, the machine language. And then the lowest level will have to do with the computer hardware. So from here, you see that each level relies or uses the complexity of the next level to solve what is before it. Let me draw the diagram for this so that it's clear. So we have your problem here, the problem you want to solve. And then the language, the high level language, programming language, high level programming language, which could either be Java, Python, C++, etc. Then the next level, we now have to deal with your compiler, stroke, interpreter, either of the two, depending on the language you are using. After this, we have the assembly language. That's the language that is next to the high-level language. And then you have the machine language, which is what the hardware of the computer understands. Machine language. And then we have the computer hardware. So what we are trying to say is that this hello world that you have seen now is just hiding a lot of complexities. So what you see is just the programming language you have used to solve the problem and every other thing that works for you to get the result of that um, code to be displayed on your screen. Every other thing that works together to get that result is being hidden from you. And then if you want to address any of this as a user of the system, you'll be limited. And what will limit you is your understanding of the layers of abstraction. If you are good in machine language programming, you'll be able to understand what is happening at that level. If you are good in assembly language, you'll be able to understand what is happening here. If you are good in the compiling or interpreting aspect, you'll be able to understand what is happening there. And if you are good in the programming languages too, you'll be good in understanding that. But if you are not good in any of these areas, what you will do is just to see hello world being printed on your screen without knowing how it got there. Okay, so I think a better example now that is going to be clearer has to do with the next abstraction. That's abstraction in functions. Functions provide simple interfaces to complex operations. Yes. So we usually use functions to kind of organize our programming into modules. For example, when we are performing some operations several times or regular basis, you may need to just say, okay, instead of me when calling that function or using that operation all over again, let me just create a function and call it anytime I need that particular operation to be done. So for example, if you have this function of calculating a particular score, and that score involves a lot of multiplication and addition, you can create a particular function that you will call to just say, okay, let me call solve. So anytime I call solve, I get the result of that operation. So a function hides a lot of details from the user that is using it. And so that's the reason why you see so many programmers. What they do is they use libraries, they call functions, but they don't need to understand what is happening behind the door. The only thing they need to know is that, okay, what is the function doing? What are the requirements for the function? What are the inputs and what are the outputs? And what is the name? That's what they are bothered with. Whatever is happening within the function, they are not bothered with that because they just need to call the function. So at this level now, we have a programmer here. At the topmost level, the programmer that is using the function. Then the function is calling, maybe it's to calculate the average score. Calculate average score. Average is a function. So you will call the function interface, call the function, and then what is happening in the function, you may not know what is happening. You just need to know that the function is going to calculate the average of 5 scores and we call it. So under the function now, we have several things hidden. The algorithm, procedure to calculate average is hidden there. The calculations of how the average is being calculated is hidden there. The loops, in case you are going to encounter loops, everything is hidden there. The conditional statements, in case you are going to encounter if statements, is hidden there. Memory management, is it in there? Memory management, to how the memory is being managed, is it in there? Error handling, how errors are being handled. Everything is within the function. Error handling. So what we are saying is that the function too is a way of abstracting what is a way of hiding details from the programmer. So he may or may not understand what is happening in calculate average function. And if he understands well, if he doesn't understand, it's okay as long as the function works. So this separation allows programmers to use functions without understanding every internal detail. The benefit of using functions is that it simplifies programming, promotes code reuse, improves readability, reduces errors, makes maintenance easier, encourages modular design. So we have several examples of such functions in different applications and in different scenarios. So the essence of using functions is to abstract what is happening behind the door, to hide all the details of complexities behind those functions. So the calculate average score is a simple one, but you can see examples of different types of functions. For example, in games, when you are playing games on the system. For example, we are playing some games. You can see some functions like move player. You can see functions like save game, etc. So what is happening within the move player, you don't know. What is happening within the save game, you don't know. A lot of things are happening behind the door. Loops, calculations, algorithm, conditional statements, a lot of things are going behind. Yeah, all these are hidden, but you are playing your game. For example, scientific software. There are some scientific softwares too. What is happening behind is that maybe they solve equations for you. You don't know how they will solve them. Oh, it's just going to be a function, solve equation. They compute average or mean for you. It's a function. Everything is hidden. They plot graphs for you. They plot graphs. You just call the function to plot the graph. You don't know how the graph is being or what they are using to plot the graph. You only just to use plot graph and you get your results. So those are examples of abstraction in functions. The next one has to do with abstraction in object-oriented programming. So what is object-oriented programming? This is a process of modeling real-world objects by exposing only the external attributes and behaviors while hiding unnecessary implementation details. It enables programmers to focus on what an object does instead of how it performs its operation. So abstraction in OOP focuses on what an object does and not how it does it. How do you achieve abstraction in OOP? We use abstract interfaces. Sorry. So we use abstract interfaces, abstract classes and interfaces, sorry, classes, method, and objects to achieve abstraction in object-oriented programming. For example, now, um, in case you have a programmer The programmer is working with an object he calls a bank account object. So we're only exposed to the methods and the attributes of that object in the object-oriented programming. So the next thing is going to define the method of that object. And I'm just trying to simplify this for you. And the attributes. So when you talk of account now, you have some things you do on the account: deposits, withdraw, and get balance. Deposit, withdraw, and get balance. So at this level, you're only exposed to what you need, not how to do it. So you are not bothered with how to deposit, how to withdraw, or how to get the balance. What you need is just the methods to get them. So abstraction hides internal implementation from the user. And let me use an analogy if this one is not too clear to you. For example, now, when you watch your TV, when you are watching your TV, you have a remote control. Don't you use a remote control? Remote control, the remote control that you use has some buttons. You can increase the volume, you can increase the volume, you can reduce the volume. You can change the channel up, move up or down, depending on the station you are. If you're in station 1, you can move to 30, and 30, from 30, you can move down to 27. So you're using your remote control to move up and down and to increase and decrease the volume. But it's more than that. You are doing all that without knowing a lot of things about your TV. You are doing all that without knowing how the connection between your remote control and the TV, how these signals are being decoded, how the hardware adjusts the sound and changes the channel. All these complexities are being hidden from you. Everything being enclosed in the remote control. And the only thing you need to do is to push buttons up and down. So the remote exposes only the essential functions while hiding the internal implementation. So that's an analogy for you to explain the concept of abstraction in OOP. So the next one we have is the one on online banking applications. Online banking is similar to the ATM I just mentioned. The only difference is that here you are not using an ATM machine. You are doing the banking via your app or your web application. So interacting with the web application involves some levels of abstraction too as well. Your web browser too, as the example I use, once you launch your web browser, what happens between when you enter your address and receiving your content on the browser is a cycle. It's always usually called request response cycle. It's a whole cycle which is hidden from the user. You just wait a few seconds and you see your content on your screen. So a lot of abstraction is being done there at that level, hiding a lot of details from the user. So we now want to, apart from all these scenarios that we have discussed, we also have a concept called encapsulation. So some people usually think one is similar to the other. No, abstraction hides complexity, while encapsulation has to do with the data. It hides data so that different concepts are not the same. One is hiding complexity and one is hiding data. So the advantages of abstraction have been mentioned the other time: readability, maintainability, reuse, and scalability. And the limitations, because we always have limitations to concepts, just like we have limitations to analogies. It increases performance overhead, it hides details, and it gives us debugging challenges. Okay? When you depend too much on abstractions, you have a lot of issues. Some applications cannot survive, or you may not even be able to work on any application if you use too much abstraction. And then sometimes abstraction may cause delays, unnecessary delays, which may prevent some uh, developers from making strict performance requirements. So when they cause so many delays, because you're abstracting, you're hiding a lot of things, it may cause some delays that will prevent those working on the project to achieve their aim. And then high-level abstraction generally requires more system resources than lower-level implementations. So you have a lot of issues caused by abstractions. It causes a learning gap too. For example, someone trying to understand a concept and cannot understand the complexity behind that concept. You'll be limited and the gap will be there. You cannot feel it. It causes a lot of misunderstanding. Yes, when you are only limited to one aspect of a large concept, understanding will be very, very difficult at that stage. And it reduces control. So you have a lot of limitations caused by abstraction. But nonetheless, we still need them to be able to solve problems. And so many applications are there in software engineering, databases, networks, AI, and web development. Okay, before we summarize this, maybe I'll have to give you one small assignment too, just like I did the other time. I want you to apply abstraction. Give me the different layers of abstraction related to, give you an example. Okay, user interfaces. User interfaces. Abstraction in the context of user interfaces. So that's your assignment. Discuss abstraction in the area of user interfaces. Did you get the assignment? Did you hear the assignment? Yes or no? Abstraction. Yes, yes. Yes, correct. Okay, I got it. Okay, so you send it to my email address too, like you did the other time. And another one. application of abstraction in artificial intelligence, AI. Let's see what you can write on that. Application of abstraction in AI. That's the second one. So the summary is that abstraction manages complexity by exposing essential features. Abstraction is a superpower for the human brain. It allows us to navigate a complex world without being overwhelmed. Mastering abstraction means knowing which details to ignore and which to keep. And final thought, simplicity is the ultimate sophistication. So that's the summary of our course. Is there any discussion, question, comments? So any area or any concept you are exposed to understand it better, maybe you first of all arrange it into layers and you start from the highest layer. You start understanding the concept from the highest layer and gradually move down to the lowest layer. So the one you are comfortable with is the one you start with. If you know you are not comfortable with some, you leave them out and focus on the one you understand. And gradually be able to solve any problem in that area. I'm not saying you should know everything about that area, but if you use the layers of abstraction on that particular concept or theory or design, then definitely you should be able to get something out from what you want to achieve. Anything you want to achieve is achievable using abstraction. So I'm expecting my assignment to be sent to my email address. So I'll still package the slides for the last lecture and this one and send to your class rep. I'll send you the slides. Or send the assignment to my email address. These two to my email address soonest Friday morning. And be expecting your slides to be sent to you latest Monday morning next week. Because I still need to update the slides. Most of what I mentioned or discussed are not in the slides. So I need to take my time to update your slides and send to you, add all the drawings and extra informations that were mentioned to it so that it will be explanatory and comprehensive for you to understand. Is there any question, comment that you have? Can someone briefly summarize what I've been saying since we started? Just three items. Just mention any three items I mentioned about. Just three. So that I know that you got something from this class. Mention just three aspects of my slides. I don't know the number of you that are around, but just anybody should just come out and mention three things I mentioned today. Before I close the class, just mention any three aspects I mentioned today. I'm not seeing any response. I need you to mention any three aspects I mentioned today. I mentioned so many things. I just want someone to mention three out of them. I'm waiting. You're saying, okay, ma. Oh, oh, thanks a lot, ma. You're not saying anything. Any three. Okay, I mentioned, what did I do? The first time I mentioned layers of abstraction. Yes or no? Layers of abstraction. That's one thing I discussed today. What else? What is abstraction? Why do we need abstraction? Why do we use abstraction? ATM, car, fine arts, technology. That's what I want from you. Just three items of my slides to be mentioned before you go. Anybody? I mentioned encapsulation, ATM modules. Yes, ATM modules. Yes. Yeah, I mentioned them. That one will help you to remember most of the discussions. Another person, this one asked, okay, we talked about ATM module. What else? We still have time, oh. It's not yet 6. I'm expecting responses from you. Someone has said ATM module. What else? Okay, is it that you're the only one in the class? Because you're the only one responding to me. Michael Akinlolu. Who else is around? Michael Akinlolu. Emmanuel Tunde John. Emmanuel Tunde John. Answer me. What did I discuss today with you? Adedayo Adebayo. Adedayo Adebayo. There's only one person answering. What of the others? Where are they? What are you doing? Are you sleeping? Wake up. Adebayo Adedayo. Answer. Someone said we talked about language like machine language. We talked about high level language. I just mentioned them. I didn't talk about them. Who else? I'm expecting more answers. I said a lot today. Why is the class so dull? I understand the fact that this concept is complex, not straightforward like that one I did last week. It's not something you can really understand, but just understand it's 50% of it. It's okay. Abstraction works in user interfaces with the computer, like when we click a button, we only see the results on the screen. Yeah, we mentioned something like that. What else? What I'm expecting from you is to give me layers of abstraction when I talk about user interfaces. Give me layers. Hmm. Abstractions. Yes. What did we say in abstractions? What? I'm still expecting answers from you. Michael Akinlolu, are you there? Oyindamola Aluko, are you saying that you did not understand everything from start to finish? You are saying no problem, ma, no, ma. You don't understand. Okay. In clicking a button, the input device communicates with the OS. The OS accesses the CPU. The CPU responds, and when the OS transfers data to the output device. You are just giving us the process, the flow from clicking a button downwards. But you did not arrange this in terms of layers. Which one belongs to the highest layer, middle layer, and low layer? If you arrange it that way, do you understand? It's a good flow, but you should arrange it in terms of layers of abstraction. Which one is peculiar to the user? Which one is peculiar to the engineer? Understand? Which one is peculiar to the programmer? That sense, you see things clearly and you know which one to address. This one is just a faint view of what is happening. It's not detailed. More examples. Who answered the question? Fantastic favor. Okay. Mm. Michael Akinolu, are you there? If you are there, answer. Emmanuel Tunde John, are you there? Fawaz Adebayo, I'm waiting for your replies. I need more answers, please. I'm waiting. So it's only fantastic favor, Abdullam, Abdul Muis. Just two students answered me now. The others, two out of, I don't know your population, but it's just two out of the lot that answered my question. What's happening to the others? Are you sleeping, or you just want someone to just talk and then you copy the slides and download the slides and read? So I only have two students today. I'm going to take the attendance or note their names and give them extra marks, bonus. Fantastic Favor and Abdul Muiz. Those are the two students that will receive additional marks. Aha. I should repeat the question. Okay. What I said is, what two things can you go away with or get from my slides? Three items you can get from my slides. Don't need much explanation. Just mention them. If it's ATM you heard, just write it. Anything you heard from my slide that you can just bring out from my slides, just mention them. I've been talking for at least 1 hour. Talk. So I want you to bring out what I talked about. If it's abstraction, just write it. Just write something. And if it's the assignment you're trying to answer it. And the assignment say that okay, why we need abstraction? Okay, so answer the question. Why do we need abstraction? Oluwa, Demilade, Olaniyan, answer that question. Why do we need abstraction? Why do we need abstraction? To reduce complexity, to improve understanding, and to enhance productivity. Right, correct. So you are listening. Okay. Who else? So I have three now. Olademilade, Olaniyan. Fantastic Favor. And Abdul Muiz. Three. What the others? Continue. You still have time. I'm expecting your own responses. I will note those names. So. Olademilade, Olaniyan. Abstraction exists on high level, mid level, and low level. And those are layers of abstraction. Layers. So abstraction is one and it has layers. It has levels. High, mid, and low. Okay. So you have joined them. Dominique the Code, Oluwademilade Olaniyan, Fantastic Favor, and Abdul Muiz. Just four students have answered me. I know their names. I'm still around. I'm expecting more answers. So I have Dominic. I'm noting your names. Dominic, the code. Fantastic Favor. Oluwademilade Olaniyan. Fawaz Adebayo. Abdul Muis. Only 5 students are in the class. If you are there and you have not answered, answer now. We have few minutes left. So that before we close the class, I only received 5 responses. The others should answer now. Just find something to say about today's lecture. Just find something to say. I'm noting your names. Those that answer will get some marks, extra marks, like 5 marks. So please answer now, or it's too late. Oyindamola Aluko, are you there? Emmanuel Tunde John. I'm waiting. It's not yet 6. Abstraction is also used to promote code reuse. Or abstraction promotes code reuse. Yes. What else? Okay. Ade Shipo Paul. Yes, now. Ade Shipo Paul. 5 marks. Who else again? You still have time. This is how many minutes to 6 now? I have 16 more minutes. All of you can quickly send your responses before 6 so that I can note your names and give you your extra marks. I'm waiting. Michael Akinlolu. Oyindamola Aluko. So for your assignment now, I said you should discuss abstraction in artificial intelligence. Okay. So you have one of them is symbolic. You have three types: symbolic, sub symbolic, so after discuss them and give the core benefits of these abstractions in AI. It is 5 minutes to 6. So I should conclude that only 6 students attended the class. Is that it? Only 6 students. Mola Luko, I asked you, you didn't answer me. Huh? Oh, yeah, send your answer now so that I can add you to the list. Just anything that has been discussed today, just mention it. That's all. Before 6. Just mention something I discussed about today so that your name can be added to the list. If it's abstraction, you remember, just write it. You have 3 minutes more. I'll close the class now. You have nothing to say. Three minutes to go. Any other person? So the 5 marks are only for Dominic, the code, Fantastic Favor, Oluwadamilade, Fawaz Adebayo, Abdulmuiz, and Ade Shupo Paul. Those are the ones that will get the 5 marks. The others, you're not in class, or you're in class and you did not listen, or you're in class and you did not understand. Is that it? Is that the conclusion? Yes or no? 2 minutes to 6. So you can still salvage the situation by submitting your assignment on Monday, on or before Monday morning, and you get your marks back. So thank you for coming today and listening to the class, to the lecture. We use this to close the class, and we see you next week for another series of COS 102 lecture. Thank you. Bye for now. God bless.